is we're going to look back from 4.5 billion years ago when the Earth was just forming. To now, and I'm just going to try and give you a few key things, sort of landmarks, as we go along. So, about 4.5 billion years ago, there was methane, carbon dioxide, ammonium, hydrogen gas, nitrogen gas, water, but importantly, no oxygen at that point. Now, there's a lot of debate as to how life initially came. One of the prevalent theories at this point is there's something called an RNA world. This is just a hypothesis in which it's thought that perhaps the molecule RNA, which we'll talk about, played role as both something that was able to catalyze chemical reactions and therefore did things actively and also stored information. But in any case, the best guess is that the first life that was about 3.8 billion years ago, somewhere in that vicinity, it was something that probably resembled most closely a present-day bacterium, a single-celled organism, something like that. Now, initially, when life got started, it's thought that there were a lot of organic chemicals that had been made as a consequence of lightning strikes and all sorts of chemistry that had happened. So there was sort of a soup of some kinds of molecules that could be used. So probably these first organisms were able to basically use some preformed nutrients, and then as the soup began to get depleted by using it, they had to learn to synthesize, at least develop systems that would synthesize these building blocks. And they also had to begin to worry about what to use as energy. And so somewhere in here, there's something that I'll call, in a silly way, photosynthesis release number one. But this was a system that enabled the organism to capture sunlight from energy from sunlight, so that it wasn't now dependent on getting energy by eating some preformed ingredient. It was then able to take carbon dioxide and make it into forms that were useful, of carbon that were useful for life. And it produced molecules such as sulfur as a waste product. There was a bit later in evolution, somewhere in here, something we might think of as photosynthesis release 2. This was an improved version of photosynthesis. It was captured more energy, worked better, but it had a waste product, which was oxygen. Well, oxygen hadn't been in our atmosphere, and the first thing that sort of happened was that the world started to rust. All the iron, a lot of the iron started to interact with the oxygen, and Penny will tell you that at the base of the sea there are huge beds of iron oxide that came from this slow rusting of the earth. And so it took many, many years before oxygen levels started to rise. As you know, it's about 20% of our atmosphere now. Even at this stage, it was only a few percent of our, made up a few percent of our atmosphere, even by here in evolution. The first eukaryotic cell is thought to have appeared somewhere here. Again, it was likely a single-celled organism, like some of those pictures I showed you, and evolution continued to go. Somewhere around a billion years ago, sex was evolved, which enabled eukaryotic organisms to exchange genetic material and therefore evolve at a faster rate than they could previously. The Cambrian period was about 500 million to 0.6 billion years ago, and there was a veritable explosion of life forms, and you can still see in the fossil records how much diversity was generated at that point, some of which went on to become life forms that we know, and others which probably were more evolutionary, dead ends. Finally, we get to the dinosaurs. We're about 245 to 65 million years ago, which would place them somewhere here on this timeline. So in honor of this course, I've commissioned a full-scale model here of anatomically. There we go. So we'll put our dinosaur here, if I can get him to stay put for a minute. All right. And at this point in evolution, things started to get interesting. So somewhere about here, 4 million years ago, we got the first evidence of hominoids. Maybe 20,000 years ago, we found the cave paintings in France, and then there was the Roman Empire, and Columbus discovered America, and you were born, and the Red Sox won the World Series, and the Patriots have just won the Super Bowl, and we're now here at the peak of evolution, which is, as you all know, is the MIT student. So we'll put our MIT student here, who I can probably not get to stay put, because you never get MIT students to stay anywhere. But in any case, this is sort of a silly demonstration, but there's a very profound reason why I'm doing it, and I must say I don't think I'd ever fully appreciated it until I actually thought of doing this demo for the class. But what I think you can see is that evolution, for the most part, happened at the single cell level. Many people tended to think, oh, evolution, that was about dinosaurs and all that stuff. You can see that dinosaurs are practically now. Most of evolution occurred at the level of single cells. That's all this amazing diversity we see around us was very recent embellishments in evolution. So that means that when you study biology at the cellular and molecular level, you find tremendous commonalities. If you look inside a sulfolobus growing in a hot spring, you look inside an E. coli, you look inside a yeast, and you look inside one of our cells, you find that to a huge extent, many of the cellular components are common. They arose so early in evolution that they're shared by all forms of life. Of course, there's some things that develop later and are different, but that's one of the reasons that you can learn so much by studying biology at the cellular molecular level, and why we'll emphasize it a fair bit in this course. The other thing that I'd like to make out of this theme that you'll hear along is that organisms modify their environment. You can see that in the case of oxygen. Back when the Earth formed, there was no oxygen in our atmosphere. Now we have a lot of it. The reason it's there is because it was generated by organisms carrying out photosynthesis and generating oxygen as a waste product. And that was an absolutely critical thing to enable creatures such as ourselves, which are dependent on oxygen for just to even be alive. If we hadn't had this change in environment, organisms like us couldn't have evolved. So anyway, I hope that will give you a little sort of snapshot of evolution and will help guide your understanding of this course. We'll see you at the next lecture.